Swayam Prabha. Digital India. Educated India.
Hello everyone, we will now continue with the UV radiation protective textiles. So, in last sessions we have discussed various aspects of UV radiation, and now we will proceed further, and we will start with in depth understanding of the different waves, what are their ranges of the wavelengths, so and frequency, and it will help us in understanding developing our protective textiles. Like if we see here the wavelength, these are the different radiations at the region, different region, okay, and then wavelength. So, the regions are actually based on the different types of radiations, like radio wave where we can see that this is a radio wave, the wavelength is very high. Okay. So, wavelength is given in angstrom. So, more than 10 to the power 9, 10 to the power 9, that wavelength, it's you can see here more than 1 kilometer up to say 100, so 1 meter to 100 meter. So, that wavelength of radio wave is very high and long wavelength. So, you can see it imagines on typically height of a person to maybe it can go up to a football field. So, that is the range of the wavelength. So, at that range we call it as radio wave. So, more than 10 centimeter if you talk in terms of centimeter, and frequency, here the frequency will be very low frequency, it is less than 3 multiplied by 10 to the power 9. So, that is the wavelength and the frequency here, and frequency, as the frequency is low. So, here energy, so whatever energy is radio wave is carrying, so it is very low energy. So, from the radio wave we do not have that much health hazard. So, because the energy it is carrying is very low, less than 10 to the power 5 minus 5 electron volt. Then comes the range of microwave range. Microwave is wavelength is much smaller than radio wave. So, here wavelength is typically from 10 centimeter to 0.01 centimeter. Okay. So, in that range the microwave wavelength is that, and the frequency is in this range 3 multiplied 10 to the power 9 to 10 to the power 12 at that range, and the energy which we get is we have little bit higher energy than radio wave. Still the because at the energy is low here. So, threat from microwave, although in long exposure the microwave will may affect, but it is not that high. So, next comes infrared. Infrared we get from the different sources. Here wavelength, you can see here wavelength is much lower than the microwave or radio wave, and frequency is higher, and as the frequency is higher, so that its energy which is carrying it is higher than microwave. Then comes visible light. So, visible light has the wavelength in this range, this is the visible light. Depending on the wavelength, the color changes. Okay. And we can see here, this is the wavelength, and it ranges from 7 to the power 10 to the minus 5 to 4 to the power 10 to the power minus 5. So, it is much smaller than infrared, and here frequency is higher, and energy it carries between 2 to 3 electron volt, and these are the rays. As they are carrying less energy, so our their effect on our body, immediate effect is not that high, and our basic area of concern here it is ultraviolet ray. So, why we should be worried? Because we get from direct sun exposure, we get this ultraviolet ray, and which affects our body, and the detailed effect we have discussed in earlier sessions, and the wavelength, as we have already discussed, there is a range of wavelength, and the frequency here it is high, very high frequency though. So, the energy which is it is carrying it is very high, and above that the X-ray and gamma ray, X-ray and gamma ray, you will see that here its wavelengths are much lower. So, as the wavelengths are lower, we can see their energy produced by X-ray and gamma ray are very high, and they have very high frequency. So, that is why their exposure for few seconds will affect our body physiology, they will adversely affect. So, we from X-ray and gamma ray we should be protected, we should not get exposed to these rays. But why we should be worried about UV ray? Because we get directly from sun the abundant quantity of UV ray which affect our body. So, we should be protected from the UV ray. So, for that we should develop, we should design our clothing. So, we have discussed various issues on this. Now, subsequently what we will discuss here, we will try to understand few research studies on textile fabric, particularly woven fabric, how different parameters affect. Now, if we try to understand the spectrum of visible light, so visible light spectrum in earlier situation we have discussed, this is the range of visible light. So, the visible part of the spectrum may be further subdivided. So, that visible part we can subdivide based on the frequency, and depending on the wavelength the color changes. The red at long wavelength and the violet at short wavelength. So, we can see this is the short wavelength because wavelength is reducing, and this is the longer wavelength. So, as the this wavelength reduces, the energy produced will be higher, and that will affect our body. So, that is the violet color affect our the human body more than the red color. Now, schematically we can see here. So, this is the red color and here is the violet color. So, here the wavelength is reduced. So, energy is high, another diagrammatic representation of the electromagnetic spectrum. So, here our main ORI is the ultraviolet zone. So, wavelength is reduced from right side to left side. This is the radio wave, here is the microwave, infrared, and this is a visible light in this zone, and here we get the ultraviolet ray from sun. So, our area of concern is this zone. For that we need to develop different types of protective textiles. So, the infrared frequency range is 3 multiplied by 10 to the power 12 to 4.3 are multiplied by 10 to the power 14 hertz. So, that is the infrared range. And visible light frequency range is from 4.3 to 7.5 multiplied by 10 to the power 14, that is the visible light range. So, it is lower frequency. So, if the wavelength is lower, and so this is the here the frequency will be higher. So, UV ray this is the range we have already discussed. X-ray, the frequency is much more, and gamma ray, the maximum frequency. So, that is why the energy increases as we go from infrared to gamma ray. So, our area of concern is the ultraviolet radiation. So, we will discuss in detail of ultraviolet protection by a textile material. So, it is a electromagnetic wave as we have discussed. So, wavelength ranges from typically 10 nanometer to 400 nanometer. The energy 3 electron volt to 12.4 electron volt. So, at that range, this range which affect our body, but fortunately the higher energy with low wavelength, they are absorbed by the ozone layer, does not reach to the earth surface, and this electromagnetic spectrum of UV ray, ultraviolet rays, can be subdivided based on the wavelength. So, we can see earlier we have discussed UV A, B, C, which normally physicists do, but for biologists they divide into 4 categories: UV A, B, C, D. D is the range with a very low wavelength. So, UVD is that carries very high energy, the low wavelength 10 to 100 nanometer. UVC range is 100 nanometer to 280 nanometer, that is the wavelength, and UVB 280 to 320 within this narrow range, and 320 to 400 is the UVA. So, as the UVD does not actually reach to the earth. So, we are not concerned about this UVD. Now, we can see according to biologist, as I have mentioned, UVA is a long wavelength, UVB is having shorter than UVA, UVC is having much shorter wavelength, and UVD is typically very short wavelength, 10 to 100 nanometer. So, according to physicists, they divide into 3 different categories. So, this is near UV, which with having higher wavelength, near UV it is 300 to 400 nanometer at that range, middle UV 200 to 300 nanometer wavelength, and vacuum UV 10 to 200 nanometer. So, that this UV rays are classified, but in our case what we are discussing the effect of human body. So, we will follow the biologist's classification, and develop our clothing accordingly. Now, we can try to see the further classification in a single place for biologist and physicist. Here UVA, this is the range we have discussed, the wavelength 315 to 400 nanometer, energy is 3.1 to 3.94 electron volt. So, these are the long black light and it is not absorbed by the ozone layer. So, we should be worried about this wavelength UVA, UVB with a little bit shorter wavelength with higher energy. This is a medium wavelength and mostly absorbed by the ozone layer, but to some extent typically around 5% reaches to the earth surface, typically 95% is absorbed, and UVC here the range is 100 to 280 nanometer and with higher energy, higher than UVA and UVB. So, 4.43 to 12.4 electron volt, and fortunately this short wave and which are used in germicidal application, and basically it affect due to its high energy, it affect the living organism significantly, and it is fortunately it is absorbed completely by ozone layer. So, 100% absorption. So, 0% is reaching. So, we are protected by from this UVC by the ozone layer, and so near ultraviolet. So, NUV it is a range 300 to 400 and visible to birds, insect, fishes. So, middle ultraviolet that we have discussed, far ultraviolet. So, in with the reducing wavelength and increasing the energy. Now, the vacuum ultraviolet VUC with the very short wavelength 10 to 200 and high energy. So, 6.2 to 12.4 electron volt, and you can see the strongly absorbed by the atmospheric oxygen. So, there as it is a lower wavelength. So, it is absorbed by the atmospheric oxygen. Though 150 to 200 nanometer wavelength can propagate through nitrogen. So, atmospheric oxygen absorbs all this low wavelength. So, it has got higher energy, but it is absorbed. So, extreme ultraviolet UV. So, within this vacuum ultraviolet, so extreme that ultraviolet which has a lower range 10 to 120 nanometer, that at that range, and with the high energy. So, ionizing radiation completely absorbed by the atmosphere. So, if the wavelength is lower, then the absorption will be higher, although those they carry the higher energy. Now, you can see how the different types of UV ray are getting absorbed. So, here it shows UVA. So, UVA with higher wavelength and lower energy. So, long wavelength they penetrate through the ozone layer, typically 95% penetration is there and 95% reaches to the earth surface, and only 5% UVA is absorbed, and UVB, in case of UVB just it is reverse, 95% is absorbed, only 5% reaches to the earth, which is more harmful than UVA, and UVC which is harmful, and it is 100% is absorbed, it does not reach to the earth surface. So, less ultraviolet, high ultraviolet. So, where normal ozone layer is there, in that case the ultraviolet ray reaches at the lower amount, but when the thin ozone layer is there, so there we can get higher UV radiation. So, depending on the location where the ozone layer is thin, there we should be protected properly by some protection mechanism that we have discussed, like particularly for by using the sunscreen, or the best way will be protecting the using the UV resistant clothing. Now, there are different effects. So, for human the effect is immune suppression, skin cancer and eye cataract. So, these are the common effect of UV on human body, and it also affects the aquatic ecosystem, the plant and overall environment, and it has great effect on different types of materials like your polymeric material or different materials. So, those get affected, polymeric degradation take place. So, for different types of material this UV ray affect adversely. With the health aquatics ecosystem like fish and some aquatic animals, they get affected, and plants and trees are affected by UV ray, and different types of materials. The material get degraded, rubber, polyester, any polymer, nylon gets affected, polypropylene, this type of different polymers they get affected, even this colors and paints, they are polymeric materials. So, they get affected, they get fade out. So, due to the ultraviolet ray. Now, how to protect against solar radiation? So, we can change our behavior. If we change our behavior, so we can protect ourselves from the solar UV radiation. So, what are these? Like we can avoid direct sun exposure between 10 mm to 2 pm, but particularly within that zone if we are protected. So, that time the exposure, sun exposure is maximum, and environment and legislation changes. So, that we can change the legislation. A creation and popularizing the global UV index by World Health Organization. So, people must know, suppose when we move from one place to another place, we try to see the weather condition, whether it is what will be the temperature, whether there is any chance of rain and all other parameters we try to, what is the pollution level, accordingly we get ready. Similarly, the UV index should be popularized, and WHO can do these things, or many other organizations they can popularize this global UV index. Change in the environment by provision of shade or other UV radiation protection structure according to the UV index. So, UV index will be for a particular environment. So, if the UV index is high, that means there is chance of more UV ray coming, threat will be more. So, in that case the structure, so protective structure can be built. So, there the portion, the location where UV index is high. So, we should develop or create the structure accordingly. Then personal protection. So, our body we can protect ourselves by using sunscreen lotion we can use, which actually prevent the direct exposure from the UV ray, or we can use umbrella hat that we have discussed, using sun protective clothing. So, the advantage of using sun protective clothing, we know that it covers whole body. So, we do not need any other additional cream or any other chemical to be applied, and it is a long term use, for long term use, and it will give the consistent UV protection. So, that is why sun protective clothing is the solution, and these are the different types of personal protection. Now, we will discuss the different terms which are used for labeling the UV ray. Ultraviolet protection factor, UPF. What is that? It is to assign the degree of UV ray protective fabrics. So, that how much UV radiation protection a fabric can provide, and that is actually expressed by UPF. UPF is basically for textile material, for clothing. So, inverse of UPF is known as erythemal weighted transmittance, EWT. okay, to assign the degree of UV air protection of fabrics. So, we can assign the number, some value which will give us the idea about the UV protection. So, UPF and EWT, they are actually inverse. Next is the sun protection factor SPF. So, mainly used for sunscreen or sometime for clothing. So, this sun protection factor is basically for sunscreen, but we can also use for clothing with but for that we need to have specific testing protocol, because we have to keep the fabric on the some portion of the skin. Next is the UV index. So, UV index is nothing to do with the protection, but it gives an idea of overall the UV level, UV ray extent or intensity of UV ray in a particular location of in the earth. So, it used for daily weather forecasting. So, you must know the what is the UV index in a particular place or in a particular time. Another labeling is the eye protection factor EPF. So, for designing the sunglasses and all this, so we need the eye EPF is a factor. So, used for sunglass. Now, what is UPF? According to ASTM or New Zealand Australian or New Zealand standards AS or NZS and ASTM standard, the UPF is defined as the ratio of wavelength. So, ratio of the effective UV radiation transmitted and calculated through the air. So, that is effective dose. That means, this is plain air, the effective UV radiation which is coming through the air, this is air and it is called effective dose. This energy which is coming and it is called ED. So, effective dose and the average effective UV radiation transmitted and calculated through the fabric. Now, we are putting a fabric and here we have the protective fabric and now the transmitted one, it is called the effective dose of fabric EDF. Okay. So, if erythemal weighted transmission, so the weighted transmittance EWT as we have discussed, it is inverse. So, EWT is inverse to that of UPF. So, UPF is ED by EDF, which is typically more than 1 for a fabric. So, higher the value means higher UPF means, that means if it is EDF, the transmittance is lower, then the value of UPF will be higher. That means the blocking of UV ray is more, so UPF will be higher. So, let us see the typical ranges of UPF and how much their percent of this ray are being absorbed. Now, you can see the UPF range. So, typically from 15 to 20 we can call it as a good protection, and the effective UV ray which are transmitted typically 4 to 6%. If it gets transmitted, then UPF range will be 15 to 20. So, if you typically around 5% is getting transmitted. So, 15 to 20 at that range we can call it as good protection, which is used for maybe with a lower intensity of UV ray, and UPF range 25 to 39. So, UPF rating. So, this is the UPF range is there. So, 25 to 39, it is very good protection in that range. So, typically 2.6 to 4% gets transmitted and reaches to our body, and the rating within this range we can rate actually in the at different interval of 5. So, in the industry they rate it at interval of 5. So, in the good protection range where UPF rating range is 15 to 24. So, we rate it 15 and 20, 25 to 39 we rate is at 25, 30 and 35, 35 being the highest between that range, and very good range is it is a 40 and above. So, excellent protection where typically more than 98%, so 97.5% are absorbed, only less than 2.5% gets transmitted, and we rate like 40, 45, 50 and 50 plus. So, we can see in case of even sun protection. So, 50 plus is a very good rating. Now, coming to the sun protection factor, SPF is defined as the ratio of radiation dose to produce minimal sunburn under fabric cover. So, fabric covered to the skin to the radiation dose to produce the same sunburn with uncovered dose. So, the thing is that here the concept is little bit different. This is our say human body. Let me draw. So, this is our human body part, say like my hand. So, a body part. Now, here under fabric cover. So, we are covering the skin with our fabric. This is the fabric. now what happened, for a particular time we are increasing the dose, gradually we are trying to increase the dose, first lower dose and then we are increasing the dose. So, when we increase the dose up to say x, there we found that there is a little bit sunburn took place. So, that we record this x. Okay. And again we are doing experiment with uncovered body part without any fabric cover. There we are exposing with ray, we are increasing the ray, and when we have increased little bit, we found that there is a sunburn started. So, this is y uncovered. So, y will definitely be less than x because it is covered, and the ratio of radiation dose. So, x and y are radiation dose. So, x by y will be the SPF, which is more than 1. So, for fabric, when we cover the body part and expose, so that will be calculated in this fashion. So, we can get the sun protection factor, and this sun protection factor is very commonly used for the sunscreen lotion. And the main disadvantage of getting the sun SPF value, because the ethical clearance is required, because we are using the human body. So, SPF is with the fabric and without fabric. MED is, that means your radiation dose. So, MED PS is the minimal erythemal dose of protected skin. Protected skin may be by fabric or may be by any types of sunscreen lotion, and MED US means minimal erythemal dose of unprotected skin. Okay. So, MED is, that is minimal erythemal dose, which is defined as the minimum quantity of radiant energy. So, basically using the incremental UVB dose. So, UVB dose we try to project here, that required to produce fast detectable readiness. So, when it's it's of skin with 22 plus minus 2 hours of exposure. So, that is the standard exposure, long exposure. So, when the dose is gradually increased, the dose of UVB radiation. So, as soon as it is detected, then we can get that value, minimum quantity of radiant energy. So, that energy we can get Next parameter is UV index. So, UV index is, it is an international standard measurement of the strength of ultraviolet radiation from the sun in a particular place at a particular time. So, why is it important? Because we, for developing proper the UV protective clothing, we must know the strength of UV radiation at a particular place. So, it is designed as an open ended linear scale. We should remember it is a linear scale directly proportional to the intensity of UV radiation that causes sunburn on human skin. So, this is actually a linear scale. So, let us see what do you mean by the linearity. So, for example, if light skinned individual without sunscreen or suntan, so light skin, so why do we need light skinned individual? Because there the color change will be visible. Begins to sunburn in 30 minutes at the UV index of 6. So, if we have 6 UV index, the lower, say typically say at lower UV index, we can see the UV index and time required to get the sunburn. Okay. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, these are the different UV index level. Now, here the time 10, 20, 30, 40 minute. Now, if a person at 6 UV index and gets the sunburn at 30 minutes. So, at this point he is getting the sunburn, and then that individual should expect, when we get the at higher UV level, say 12, he will actually get sunburn at lower one. So, he will get sunburn at 15 minutes if he is exposed at double the intensity of UV. So, double UV index at 12 UV index, that means twice UV energy is there. So, he will get the similar sunburn at half of that time. So, that is the linearity of UV index. So, accordingly we can get our exposure if we know the intensity UV index at different time, different zone. So, it represents the maximum effective radiance received on the skin surface. So, that is the total maximum radiance which is we receive, taking into account the cloud cover, all other variables in the environment, whether what is the moisture, what is the pollution level, what is the cloud. So, everything is considered and how much radiation, total radiation we are, maximum radiation we are receiving. So, we will discuss later how to calculate the with an example, calculate UV index with example. So, like UV index for a particular place will change if we go at higher altitude. So, with the altitude it also changes. So, it is obtained by multiplication of the effective radiance. So, total radiance. So, at different level of UV like UV A, UV B. So, all the radiance whatever it is coming, that radiance will be added, the total effective radiance of the solar radiation, and we multiply by 0.04. So, that means, we will divide by 25 to get a factor with the scale, typically to reach the scale typically from 1 to 11 plus. So, we have to reach to that range for better or easy understanding of the UV ray. So, 25 the factor or 0.04 multiplying factor is actually we have reached after getting the overall data throughout the world, and it has been observed that if we multiply by 0.04. So, we will be able to reach within that zone, and so that people can understand. So, one UV index means low UV index and 11 and above means extreme UV index. And we can see the range 1 to 2 weak exposure. So, we can see that continuous exposure of 1 to 2 hours, 2 to 3 hours we can have without any protection, okay, for sensitive skin or normal skin. So, that will give us an idea. So, without any protection, if the UV index for in a particular place is 1 to 2, then there won't be any significant effect. 3 to 4 is a moderate, where continuous exposure we can have from 40 minutes to 1.5 hour, 1 hour 30 minutes, that within that range. UV index 5 to 6, it is a strong UV index. So, we can be there maximum up to between 25 to 50 minutes, 7 to 8 very strong. So, continuous exposure maybe 20 minutes to 40 minutes can be there without any sun protection. If we want to be there for long time, for that we need to have protection, and 9 and above extreme strong we should be there without any protection for shorter time, 15 to 30 minutes. So, that is the overall guideline, and we must know the UV index for a particular place. Accordingly, we can expose ourselves without any protection. So, we will continue with the understanding of UV index, and we will try to give the example of how to calculate the UV index, that we will do in the next session. Till then, thank you.